Alrighty, a quick review of our exponent laws here today. This video is suitable for a grade 11 3C class or really anyone reviewing your three main exponent laws. Our prerequisite skills, we just need to make sure we understand what exponents are, what they mean, what they represent, and how they are written. We'll start off here with 3 to the exponent 2. And nice and straightforward, what are the pieces of this power that we are working with? Well, we have a base of 3. That is, whatever is written right in front of our exponent is the base that we're working with, and whatever is written right in front of our exponent is going to be the base to which the exponent is applied. The exponent is the little 2 up here in the corner. We write them as a superscript. That's a smaller number that's written to a raised level. We would say this is 3 to the exponent 2. All of this together, this 3 to the exponent 2, together creates a power. Now, we will need to be very picky with our terminology as we work through with our powers, with our exponents, because the way in which they work is picky itself. We're about to see how and why our exponent rules work. We will expand, we will cancel as required, just to find out exactly what's going on here so that we can find ourselves a shortcut, as you folks have already learned before. Again, this is not an introduction to your exponent laws video. This is just a quick repeat. Now we're working here with 2 to the exponent 2 times 2 to the exponent 3. What this means is we're working with 2 times itself 2 times, and 2 times itself 3 times, all being multiplied together. Well, that's relatively straightforward. That means we're working with 2 times 2 times 2 times 2 times 2, where I have used 2 different signs for multiplication. You've learned a dot as multiplication. You've learned a cross as multiplication. I'm just using this to differentiate between the two, but really all we're working with is multiplication. So this is really another way of writing 2 times 2 times 2 times 2 times 2. And that's nice and straightforward. You know how to handle something like that. In total, we have 5 2's multiplying together. That is, I'm working with 2 to the exponent 5. Nice and straightforward. Now, the shortcut we can work with right here is instead of expanding out our base, multiplying by itself over and over and over again, we can recognize that we began with a 2 here, we began with a 3 here. Our exponents were 2 and 3. We could add those up to come up with our 5 at the end. That's the shortcut so that we do not need to expand every single time. This shortcut works anytime we have a multiplication of powers and anytime the bases are the same. So we need both. We need a multiplication and we need the bases to be the same that we're working with. Now let's work with part B. Okay, so now we know how to handle a multiplication of powers. Let's see when we have a division of powers. Here I have 2 to the exponent 5. That is 2 times 2 times 2, as we just saw, times 2 times 2. Good job, there are 5 2's. All divided by, all over, 2 times 2 times 2. Well, that's all well and great. I have some extra stuff going on here because I know that 2 divided by 2 is just another fancy way of writing 1. And I know as well that these 2's are a fancy way of writing 1, and these 2's are a fancy way of writing 1. I cannot do that again because I have run out of 2's in my denominator. So what I'm working with really here is like 1 times 1 times 1 times 2 times 2. And we know that if we multiply any number times 1, it does not change the number whatsoever. So really there's no need to write these first 3 1's. I'm just working with 2 times 2. Now if I'm working with just 2 times 2, I know how to write that because I'm not brand new to exponents. I can write that as 2 squared. Now our shortcut to get from a division of powers to a single power is we're going to leave our power the same. Now this works if we have the same base that we're working with in the numerator and in the denominator of our powers. We have a 2 in both. We will stick with a 2 as our base and we will simply subtract the exponent. So I could work instead with 2 to the exponent 5 minus 3. That is 2 to the exponent 2. Fantastic. That's our way, that's our shortcut in the future so that there is no need to expand, there is no need to cancel. Lastly, we have a final exponent rule that we'll work with here. This is a power of a power. You have a power of a power if the base of one of your exponents is a power in itself. I'll say that again. If one of your exponents has a power as its base. In this case, the base, as we discussed, is what's written immediately before the exponent. Well, written immediately before this exponent is a bracket. So that means everything inside these brackets is the base of this exponent 5. That means we're working with 5 to the power of 3 to the power of 5. Well, that's fine. I know how to work with that. That's just like 5 to the power of 3 times 5 to the power of 3 times 5 to the power of 3, and I can keep going, and I can make sure that I write that out 5 different times because that's what my exponent is. Well, if I'm working with that, thanks to the handy-dandy rule that we learned in Part A, our multiplication of powers, we can just add up all of these exponents and leave the base the same. Really, we're working with 5 to the exponent 3 plus 3 plus 3 plus 3 plus 3. And because we're not new to this, we understand that repeated addition is just multiplications. We're working with 5 to the exponent 3 times 5. That is, we're working with 5 to the exponent 15. That's our shortcut. In the future, instead of expanding all of our powers out here, we can just multiply our powers when we see ourselves with a power of powers. Now, using those new rules, what I want you to do, I want you to pause the video here and I want you to try out all 3 of these questions. I want you to try and find the mistake that I made, unpause the video, and see how you did. Because we're jumping right in. Question A, the trap. This person who has attempted this problem understood the goal, and the goal was to end up with 1 power. Fantastic. They did that. They saw a multiplication in the middle, so they multiplied their powers. That's the trap. We've already practiced that if we are multiplying our powers, that means we're adding our exponent. So rather than having 3 to the exponent 30, we're looking to work with 3 to the exponent 5 plus 6. That is 3 to the exponent 11. Easy. Okay, well, again, we've tried in part B here. We have tried x to the exponent 6 divided by x to the exponent 2. We see this division, we recognize, okay, 6 divided by 2 is 3. That's a trap, right? If we are dividing our powers, according to the rule that we just broke down here, if we are dividing our powers, we must subtract our exponents. So rather than to the exponent 3, we're working with x to the exponent 6 minus 2. That is x to the exponent 4. And part C, whoever has worked with this is they've multiplied this 10 by 4, they've multiplied the 10 by 13. That's a trap. Our base must stay the same. They've handled the exponent correctly, but the base must remain the 4, the original 4 that we were working with. This is 4 to the exponent 130 rather than 40 to that exponent. So you have now seen some mistakes. You have now seen them broke down. I trust you can work through some practice problems. Nice work.